Okay, so this is the last section of chapter 10 that we're going to cover, and it's going to be more stuff on apportionment, but this time we are going to be using standard divisors and make that a little bigger, standard quotients to do apportionment. And we're going to show how the population and new states paradoxes can occur with the Hamilton method, but we're then going to go on and work with the Jefferson method, the Adams method, and the Webster method, which are all very similar. It's just that Jefferson always rounds down, Adams always rounds up, and Webster, he goes up or down or up or down. He kind of, he basically uses standard rounding rules. So sometimes, it depends on, that rule that if the number to the right is 5 or greater, you round up. But if the number to the right is less than 5, you're really rounding down, but you don't change the number. Anyway, I'll cover that again, but that's the only difference. The whole method is the same. It's just how they round. But anyway, let's start with back when we used the Hamilton method, we actually calculated you would take the state's population, you would divide that by the total population, which gave you the percentage, and then you multiplied that times the number of representatives being allocated. That's what we did in section 10.1. And then, of course, he would look at, okay, you get the whole number, and then if there's any seats left over, he'd give it out to whoever had the largest fractional part. Okay, so what they did, and they utilized a little bit of algebra here, they're using S. Sorry, I must have hit a button on my screen. Here we go. They use S as the state's population, so I'm highlighting those all in blue, and they used T for the total population. Here's all the T's in pink, and N, which is the number of representatives, is all in N. Okay. When you look at this part right here, that is what this is saying. All right. Take the state's population, divide it by the total, and multiply times N. But N over here is really like N over 1. So if you have S over T times an N over 1, that would give you the same result if you had S over 1 times N over T. I don't know why I wrote a 6. That should be a T. Because when you do numerator times numerator, you're multiplying, go with green, you're taking S times N over T times 1. This is S times N over 1 times T, which is the same as T times 1. So they were able to just rewrite this equal to that, because it's like you're just given the 1 over there. Okay, and now, when they went from that to over here, they're saying that when you take, trying to find some space here, when you have S, this one right here, I guess I should put that in the matching color, huh? Boop. This one right here. If you have S times N over T, that would be the same thing as S divided by T over N. You know that rule in fraction land? And most of the time you go backwards. You go from here and change it from division to multiplicating by the reciprocal, right? They just did the flip of that. They went from multiplying to dividing by the reciprocal, which works. They're the same value either way you look at it. And then what they did is, instead of using this division symbol, they've got S divided by T over N. That's what they wrote here. S divided by T over N. And so, on the next slide, what they call this is, when you do the T over N, let me go back one more, T over N. T over N. T was, let me go back to my highlighters here. T was the total population, and N was the number of representatives. So that's your denominator underneath the S, and S was my state's population. Okay, so this division line is really important. What they're going to do is they're actually going to calculate that on the bottom and divide it into S. And what they call the denominator, which is the total population, which was the yellow, divided by the, I'm sorry, it wasn't the yellow. What was total population? Total population, oh, that was the pink, my bad. Pink. Total population divided by the number of representatives. And they're giving this a name. They are calling that the standard divisor, because the whole thing is in the denominator, right? Then they're going to call the actual division, which was S over, this is the standard divisor. The standard divisor is now called T over N. That is this, too many colors, in the pink, which is this mess right here. That's the standard divisor. So I guess I should give it a new color. How about this obnoxious blue color here? Standard divisor. That's going to be your new denominator. But the state's population, that was always S, which was in that light blue color. So, in order to do the apportionments, the first thing they're going to ask you to find, this will be step 1 here, is please find the standard divisor. So you'll just take the total population and divide it by the number of representatives being allocated. See, before, when we would take our individual population, you know, it was like the population of state A, the population of state B, and then we divided it by the number of seats that they already had. We called that the AC, the average constituency. This is a little different. You're taking the total population and dividing it by the number of representatives to be allocated for all states. And they call this the standard divisor. And then step 2, they're going to ask you, hey, please find the standard quota. So you would take whatever S is, the state's population. Now you're going to go to the individual states and divide each one of those by the standard divisor. So I'm going to do an example of that, but I don't have enough time in this one video. So next video will show that.